This video is the next video in the coordinate geometry of the line set of videos. In particular, this is looking at coordinate geometry of the line worksheet number 11, and that's focusing on area of a triangle, and particular area in a triangle when you're dealing with coordinate geometry. So if you've drawn a graph and you're asked to find the area of a triangle, check if one of the sides is either on or parallel to either the x or y axis. And if this is so, you take the side that is either on the x or y axis as the base of the triangle, and you should be able to read the length of the base from your graph. And you should be able to read the height of the triangle from your graph too, of course, because we know the perpendicular height, we should be able to do it. Then you just use the general formula that you would have used in primary school for calculating the area of a triangle, because the area of the triangle is just half the base by the perpendicular height. Now, an example that we might have is the diagram below shows two lines, P and Q. Find the area of the triangle formed by PQ and the x-axis. So we've a few lines here, so we have this line here, this line up here, and finally the line that goes down here. And they form a triangle that we have. Now, to go back on that, what we need is we need the base and we need the perpendicular height. Now, it says that if you have the x or y axis, take that as the base. So in this example here, we're going to take the base of from -3 up to 10. Then, if that's the base, the perpendicular height is going to be from the very top point down to the base. So that's going to be this line here. And what we need to do is we need to figure out the length. Now, we have the area formula, and that's just going to be half the base times the perpendicular height. The base then, well, the base goes from -3 all the way up to 10. So that's going to have 13 units in length. So the base is 13 units in length. Then the perpendicular height. Well, the height starts at 0 and it goes up to 6. So in total, that's going to be 6 units. So then to get the area, we just fill that in. The area is equal to half the base, which is 13, times the perpendicular height, which is 6. If you type that into your calculator, you'll get the answer of 39. And then, of course, this is units squared, because we're dealing with area, so it's always going to be 2 dimensions, which is squared. So if you've not drawn a diagram, or been given one, I suppose, and you have none of the sides of the triangle are parallel to the axis, you'll have to use the area of the triangle formula. Now, the area of the triangle formula is on page 18 in your formulas tables booklet, and I'm going to highlight it here just so you can see it. So it's the area of a triangle is half the modulus of x1, y1 minus x2, y2. This formula only works when one of the vertices, and that's the corner, is 0, 0. Now, this is really, really important. Put the x and y coordinates of the other points, not 0, 0, into the formula. If none of the vertices are 0, 0, you must move one of the corners to 0, 0 using a translation. You must then remember to move the other two corners by the same translation and then use the formula. Remember that the straight lines simply means that if you get a negative answer, ignore the minus sign, because a shape can't have a negative area. Now, I'm going to go through a few examples so that this makes sense, because I know there's a lot of information being thrown at you there. So example 2 here says A is -5, 3, B is 4, -6, and C is 0, 0. And they're the 3 vertices of a triangle ABC. It says find the area of a triangle. So we haven't been given the triangle, so it's not drawn for us, and we don't know if the sides are parallel to an axis. So the safest thing to do here is to get the area formula. And the area formula is half x1, y2 minus x2, y1. So we have 3 points, and to use this formula, one of the points must be 0, 0. And thankfully, here we have one of the points is 0, 0. So to figure this out then, we just need to label the points that are not 0, 0. So we have A, which is -5, 3, and B, which is 4, -6. I'm going to label this x1, y1, and x2, y2. To get the area then of this triangle, its area is equal to half. Now x1, which is -5, by y2, which is -6, minus x2, which is 4, by y1, which is 3. So the area then is half. -5 by -6 is 30. and 4 by 3 is 12. So 30 minus 12 is going to give us 18. So we have half of 18 then. 18 is positive, so we don't need to worry. So the area of this triangle is going to be 9 units squared. Example 3 has the points P, Q, R, and it wants us to find the area of the triangle. Now if you look, you can see that P, Q, and R are none of them are 0, 0. So we're going to have to make one of them 0, 0. To do that, the first thing you should do is write out the points. So we have P, which is 2, 5. We have Q, which is 4 minus 2. And we have R, which is minus 1, 3. Then we can change P to 0, 0. And how did we change P to 0, 0? Well, on the X, we'd have had to minus 2, and on the Y, we would have had to minus 5. So we must do the exact same to all of the points. So Q is going to change to 4 minus 2 is 2, and minus 2 minus 5 is minus 7. Or we have minus 1 minus 2 is going to be minus 3, and 3 minus 5 is going to give us minus 2. Now we have 3 points, and one of the points is 0, 0, so we're able to figure out what the area of this triangle is by using the formula. And it's a half modulus x1 by y2 minus x2 by y1. So the 2 points we have, we're going to have to label them, and I'm going to label 2 x1 minus 7 y1, and then the other point is x2 y2. The area then, we have a half. x1 is 2 by y2, which is minus 2, minus x2, which is minus 3, times y1, which is minus 7. Here then, we're going to get a half. 2 by minus 2 is minus 4, and minus 3 by minus 7 is plus 21. So we'll get a half of minus 4 minus 21 is minus 25. We have the modulus sign, so that's going to get rid of the negative sign, so it's going to be 25. And half of 25 is 12.5 units squared. Example 4 then is very similar to the last example that we did. So we have 3 points and we're told to find the area of the triangle. So again, we need to make one of the points 0, 0. So we start by writing out the 3 points. So I'm going to make D 0, 0. And what did I have to do to make D 0, 0? Well, I plussed 1 on the X and I took 2 on the Y. So with E, I'm going to plus 1 to the X and take 2 from the Y, and it's the same for F. So I'm going to plus 1 to the X and take 2 for the Y. So when I do that with E, it's going to become 3, 3, and when I do that for F, it's going to be 6 minus 5. Then we can get the area. So the area of a triangle So we have the formula, it's half modulus x1 y2 minus x2 y1. Then what we're able to do is we're able to label the points that we have. So 3 is x1 y1 x2 y2. Filling that in then, we get a half x1 3 by y2 minus 5 minus x2, which is 6, by y1, which is 3. Then this is going to become a half. 3 by minus 5 is minus 15, minus 6 by 3, which is 24. Minus 15 minus 24 is minus 39. The modulus makes it a positive, so it's going to be half of 39, and half of 39 is 19.5. So the area of this triangle is 19.5 units squared. Looking at some of the questions that you're going to do then, question 1 it says find the area of the triangle whose vertices are, and it gives you a list of A to F. These ones are easy because, as you can see, for each one we have 0, 0. 2 then says A, B, and C are vertices of the triangle. It says by using a translation, so by translating 2, 3 to 0, 0, find the images of B, C under the translation, and then find the area. So very similar to the last two examples that I did. 3 then says by translating one of the vertices to 0, 0, find the area of each of the triangles whose vertices are, and it gives you A to D to answer there. That should be fine, exactly like example 3 and 4 that I did. Question 4 and 5 are asking you to find the area of a quadrilateral, remembering that a quadrilateral is a four-sided shape. So when you divide that four-sided shape into two, you're going to get a triangle, so you can get the area of the triangle. It might be best to draw out the coordinate plane, plot the points, and then figure out what point you're going to use to get the area of the triangle. Multiply that by 2 to get the area of the quadrilateral. Question 6 is telling you that the line 2x minus y minus 4 intersects the x-axis and y-axis at 2 points A and B. It wants you to then find the area of the triangle OAB, where O is the origin. So you need to figure out where it intersects the x-axis, where it intersects the y-axis, and then it wants you to get the area of OAB, where O is the origin. Remembering that the origin is 0, 0. So you get 1 point, 2 point, and then you'll have the origin for the third one. It says find the area of the triangle whose vertices are 0, 0, 1, 3, and 2, 6. What conclusion can you draw from your answer? So it's hopefully easy enough. And then question 8 says find the value of k if the area of the triangle is 7 squared units. Now this, remembering you have the origin here, so you're 0, 0, and you're working backwards this time. I would start off by writing down, well, the area is half times x1, y2 minus x2, y1. Fill in the information. We have here the points. We have x1, y1, x2, y2, and we know that the area is 7. So you'll end up with 7 is equal to half x1, which is 4, times y2, which is k, minus x2, which is 6, minus y1, which is 3. And you'll be able to then work out what the answer for that is. If there is any questions, I will go through this in class. Question 9 then, the final question, says write down the coordinates of A, B, and C, and hence find the area of the triangle. That should perfectly be fine. You're just going to have to translate A, B, or C to 0, 0, and then you can fill it into the formula.